Okay, pure chemistry here. Let's go. Calcium carbide, CaC2, reacts with water to form a flammable gas, ethane, C2H2, and calcium hydroxide construct the symbol equation for this reaction. Construct the symbol equation. So we have calcium carbide. So calcium carbide, right? Reacting with water, which is H2O. Giving us what? Giving us ethane and calcium hydroxide. So we have calcium hydroxide plus ethane. Is it balanced? We just have to balance here. Then it's balanced. Also, they didn't say we include the state symbol, so it's fine. Calcium carbide is ionic. Ionic. Deduce the formula of carbide ion. What's the formula for the carbide ion? It's just C2C like that. So if you look at the structure of carbide, moving on. Figure 2.1 shows the displayed formula of ethane. So this is the displayed formula of ethane. Ethane is unsaturated hydrocarbon. Explain why ethane is a hydrocarbon. Well, anytime we hear hydrocarbon, it means a compound containing a hydrogen and a carbon, those as atoms. So here we are just saying contains only what? Carbon and hydrogen. That's all. Suggest why ethane is unsaturated. Now, there are two types of hydrocarbons, saturated and unsaturated. Saturated are those that have got a single bond, like alkanes. Unsaturated are those that have got double bond or triple bonds, like alkenes and alkynes. So it's unsaturated because it does not contain carbon to carbon single bond. So we can say does not contain carbon to carbon single bond, or you can say it contains, the carbon to carbon triple bond. The other way you can say, for something to be unsaturated, it means the carbon atoms are not fully bonded to hydrogen atoms because there's a shortage of hydrogen atoms. Aqueous bromine, it reacts with ethane. Now remember that ethane is unsaturated. And anytime we are using bromine, it means you are testing for the unsaturation of a compound. Predict the color change that happens during this reaction. They have already told us that ethane is unsaturated. And once a substance is unsaturated, well, the color changes. The color for bromine is actually orange. So the orange color for bromine changes to colorless. So it's orange to colorless. Draw a dot and cross diagram to show the electronic configuration in a molecule of ethane. Show only the outer shell electron. Now ethane, they are drawing it like this. They are writing it like this. So there are two carbon and two hydrogen. So we are that's how we are going to do it. So we are going to have that, and again that. Then we are going to have to hydrogen go and another hydrogen there. So this one here is a hydrogen and this one is a hydrogen. This one is a carbon and this one is a carbon. Now we know that the carbon has got, remember, configuration is 2,4. hydrogen is just 1. So eventually this hydrogen is going to donate an electron. Even this one donate an it will donate an electron there. It means all the hydrogens, they have donated their electrons and they no longer have electrons remaining. That means if hydrogen donates, even carbon will donate here. That means it remains with the, instead of having 4, it remains with the 3. This one also donate. Instead of having 4, it remains with 3. Okay? So now check out. Since hydrogen can no longer donate, we are dying like that. But remember that carbon to carbon, they can also be a donation. Okay? They can also be what? A donation. Because here's the thing. Hydrogen can only accommodate 2 electrons. So hydrogen is okay there. But how many are remaining here? For carbon, 3. And how many are remaining here? 3. Remember that carbon to be stable, it needs to have 8 electrons in the outer shell, but it only has 1, 2, plus 3 here, 5. Even this other one has got 2 here, plus 3, 5. So, the thing is if we donate all these electrons together, okay, let's just donate them together. 3 and this other one, 3 coming from the other one. So it's called that there are 6 plus 2, 8. 2 plus 6, 8, which means that's all. The equation for the complete combustion of ethane is shown. We are still going. It's quite a longer process. Question, by the way. This reaction is exothermic. What do we mean by it is exothermic? Now, explain using ideas about bond breaking and bond making why this reaction is exothermic. Now, anytime we talk about bond breaking, we are talking about endothermic because heat is being taken inside to go and break down the bonds. Sorry, heat formation. Sorry, when talk of yes, breaking, heat is absorbed, but well, formation heat is being released. So now the thing is that bond breaking is usually endothermic, like I said, while bond making is usually exothermic. Okay, so this they are trying to say why is this reaction exothermic? Okay, there could be a lot of ideas about exothermic reaction. All right, for example, you can talk about this one is burning, right, to give us this. So this reaction is exothermic because something is being formed. So we are saying usually bond breaking is associated with the endo, but while bond making is associated with the exo. That's why here we are saying energy is what is absorbed to break the bonds, and energy are released, making them. Complete the reaction path diagram in figure 2.4 for the complete combustion of ethane. Now, because the reaction is exothermic, how does the energy profile diagram look like? Well, you just have to know this one by heart. Now, they're saying we need to label these on our diagram: reactants, product, enthalpy change, activation energy. Now, for an endothermic, this is exo. For an exothermic, I'll write from here. For an exothermic reaction, please take note. For an exothermic, okay, we are saying the reactants are at higher energy level. Remember that this value here, delta H, is just equal to the energy of the product minus the energy of the reactants. This is how we do it. Now, usually when delta H is negative, it means the reaction is exothermic. Now, We can only get a negative number here when the products are lower than the reactants. So the reactants should be a little bit higher. So the reactants should be a little bit higher. Okay? Should be a little bit higher. Like that, then like that. That's all. So here we are going to put our reactants. Where are they? Okay, so our reactants from the equation here, these are the reactants, while these are the products. No, just copying them. So those 2H2H plus 5O2. And the product is 4 carbon dioxide plus 2H2O. Where do we label the activation energy? Well, the energy required to initiate a reaction. That is our activation energy. So just label EA there. And what is our enthalpy change? Well, our enthalpy change is the difference in the energy levels between the reactants and the products. So the reactants are there, the products are here. So the difference, like that. This one becomes our delta H. We've labeled it. That's all.